Oh my gosh, Team SUSE. Now I am mad that I didn't round out the plushies. I have so many SUSE plushies at my desk at home. I have the Geeko. I have the Geeko in so many colors. And I have a lot of SUSE shirts too. SUSE has been a great open source community member from, member company for many, many years. I've worked with SUSE back into the OpenStack days. Yay, there are our friends.
You're well prepared.
I was disappointed when I saw it wasn't there. So, and I picked the recent ones with the crack addict eyes to really set the tone.
We left the house at 5:45 a.m. This is Kube Crash on West Coast time. I've always gone east. This time Danielle came west. Kube Crash on West Coast time I'm vetoing this ever again.
Now, I'm very excited about this talk because backstage, I was watching some dancing happening. So I'm hoping during the talk, there will be additional dancing. So,
I can't believe I missed the dance.
Right. So with that, we're going to hand over to both of you. And you're not going to make me jump in and save you and ramble. So that was something we talked about in our prep for this.
Yes, and we don't need to because the audience has been so active. Keep the questions coming. I've seen wow, Robert, you've been here all day. Amazing. There's been some incredible interactivity. So keep it going. And we love it. We love all the energy out there today.
All right, over to you two.
Before you leave, are you pulling my slides up?
Yes.
Okay.
Yes,
Danielle
I am. There we go.
All the power.
Moving that, removing us.
All right. Well, I got to give you crap about not having the lizards, so I'm happy with you guys ducking out now. And to the dancing thing, I'd like to point out the very bottom of this slide mentions that I'm in engineering, and therefore you do not want to see anything remotely related to me dancing. We're low on time. I need to stop chatting about that kind of stuff. I'm excited to be here. This is my first Kube Crash. It didn't dawn on me until Mike's comment that having the word crash in the name of your conference where you may be doing a live demo is a really, really bad idea. But who am I? Thankfully, I'm not doing a live demo. So if anything goes wrong, it's really just fate coming back. But really, what am I here to talk about? A lot of what we've seen today, the idea of how do we make this as simple as possible? How do we automate all of this process? I want to talk about what SUSE is doing in our Edge team and what the difficulties we're facing in trying to automate a lot of these types of things. So first, quick introduction about myself. My name is Jason Nobies. I'm a director of engineering at SUSE. I've been involved with Kubernetes and cloud native world for probably about 8-9 years now. And then further back than that, I've done over 20 years working in open source companies and just working with open source software. Generally a gigantic nerd, in case you couldn't tell that, which is kind of one of the reasons why I'm here. So today I want to start off talking about what exactly we mean when we say edge. It's one of those terms that isn't really well defined yet, and it's I suspect it's going to end up like cloud, where everybody starts to use it without actually knowing the right definition or having different ideas of it. And then I want to tell you some of the struggles that we have bumped into and what we have come up with as a solution. A lot of this stuff is still in flux, so you're going to hear a lot of we plan to or we are aiming to as we implement it all with a fairly small team. But there's just still be a lot of good content in here. So what is the edge? Sorry, I'm keeping an eye on chat on the side. Again, an engineer. So when you see slides like this, you know I took them from PM because I do not make fancy things like this. But I do like the kind of hook it gives me to talk about what the edge is. And it's basically the easiest way is anything outside of the data center. We've broken that down into 3 different types of concepts. So the near edge, and the important thing to keep an eye on in here is the scale we have floating in the middle. So hundreds-ish of locations. Primarily here, we're talking about your telecom towers. Excuse me. How do they work in scenarios where a lot of their really beefy hardware and the important part of what they do is outside of the actual data center? Then we take it a bit further to far edge, where the scale increases by an order of magnitude. Everything from cars to I was going to say manufacturing in certain parts of manufacturing, but to your fast food chains. And then tiny edge, tens of thousands of devices. And we're talking about all of your small little individualized sensors and cameras. We've seen presentations and use cases of one of the coolest ones was about farming and all of the different sensors and the cameras they have going on to automate a particular farm. Not my talk. I'm not trying to take credit for it, but it was a really neat idea. And if you could see it applied to farming, it helps show like edge is kind of everywhere already. And we think it's just going to get bigger. So again, another PM slide. A couple things to focus on here, and I mentioned this already. It's a scale challenge. First and foremost, we are looking at numbers that we have not traditionally seen in a data center. But on top of that, being outside of a data center, we lose a lot of the existing processes and existing tools that are pretty well established for data centers, but take for granted some of the complications that Edge bring into that. We're going to talk more about that in a bit. But one of them for right now is just thinking about the networking in and of itself. How do you handle low bandwidth situations or air gap situations where you need to push updates on? You need to make sure that you are getting the feedback you need. And is it honoring the SLA you want? Can I wait for this sensor to take some time to get back to me? Or is this mission critical, like in healthcare, where you really don't want an eventual consistency when it comes to reading someone's heart rate? It's not a great look for your hospital. So a lot of different areas. You can hear me talk about a few more, and I have some example use cases at the end. But again, think scale, think how do we address these since it's not a traditional data center. These are not your normal rack nodes that we know how to answer in the past. There's no real incumbent here. We don't really have a great way of doing a lot of this stuff. I want to talk about 3 different types of options for getting new provisioning new hardware and new nodes out in the wild. On the left, we have direct node provisioning. There's network, excuse me. The idea there is I have a BMC and some credentials for some bare metal hardware. Again, outside of the data center though. So this is plugged in at a cell tower. I know how to access it through BMC, and that's about it. If you're not familiar with BMC, the idea is basically a remote API that lets us control power management and a few other things on hardware. But at the end of the day, that's all we need to be able to push from a central location all of the images and necessary data out to this bare metal hardware, power it up, detect what's on it, and then go through all of the installation and adding it to the enterprise. The opposite of that would be phone home. So you buy something from a manufacturer and you never really see it. It gets shipped out to a local coffee shop or a fast food restaurant, and it turns itself on and it wants to write back to your enterprise and say, hey, I'm here. What do you need me to do? The biggest part there, the most important aspect is how do I know who owns it? And how do I make sure that someone else doesn't come in and see this request and grab a hold of it and say, cool, this is my machine now, I'm going to have fun. And then the idea of just image-based provisioning. So when you think about low bandwidth situations, when you think about these low power machines themselves, you don't really get a chance to use a lot of the provisioning techniques we've had in the past that tend to rely on Mike, great question. But I'll come back to that about the intermittent networking, because that is a huge problem for us. But to the image-based provisioning, the idea is we want to be able to bake in everything possible. So I take this image, and this isn't an actual deployment, but come with me in the example. I put it on a USB key, plug it in, and when the machine starts up, it has everything it needs. It has all the configuration, all of its necessarily images, its Kubernetes cluster, its manifests, and everything that when it starts up, it manages to automatically begin running and serving workloads. And I wanted to quickly, last part on the kind of what is Edge. I like this slide because it shows a really easy to digest understanding of where the industry is going. And telecommunications is, I want to say behind, but I don't want that to sound negative. But in a lot of ways, they are still using very specialized hardware and software, very, very vendor specific. And a lot of these companies are looking to move away from that. Now, this is a story that has been told by, I'm sure, half of the presenters and most of the people on the call as well of, yeah, we're migrating from vendor lock-in and bespoke hardware to more industry standards. In telecommunications, we are absolutely seeing this. This is one of the things that we were looking to solve with our Edge stack as well, is how do we pull in the existing platforms, the existing orchestration engines like Kubernetes, and make them available to these types of use cases. All right, 10 minutes is still doing good on time. What makes this difficult? I love this. So this is where the engineering came in, because I have the color and the Legos, and this is where my slide is. The idea is I miss the days. I've said this a number of times, and I'll probably say it a couple more in this talk alone. I do kind of miss the days of working on just a single app where it's just like, oh, I understand all the pieces of it, and my login and everything is nice. It's not like that in the edge space. There is no single edge application that is just this does everything. Instead, we take a variety of pieces with some very varying, wildly different degrees of ownership and what they control and pull them together into a solution. Ahmed showed this earlier. This is the CNC landscape page. If you've never seen it before, realize this is maybe a quarter of it. That's about as much as I can fit onto a slide. It's gotten so scary that you almost need to look at it like an eclipse, like poke a little hole in a sheet of paper and look through that. Because if you load this thing up, it is very scary out there. But this is what I'm talking about with the products versus solutions. All of these individualized projects, as part of the CNCF, you understand there's a level of quality to that. That's not in question. But how do you get them to play nice together? How do you understand this is the database I want, this is the CI/CD engine and the service mesh and so forth? If you are brand new to the industry, or if you're an emerging company that is just starting to move into cloud native, this is very, very scary. So this is what I mean when I say we're moving from products to solutions, and that's absolutely key in Edge because there are so many different moving pieces that we would never want to re-implement all of this with a single vendor lock-in type of solution. So instead, and I'm not here to read our actual selections, but instead I want to use, it's funny, Joe, you say scary because I've told people I use that image to scare people. Whenever they're like, oh, this is all open source, why do I need you? And then I pull that up and everybody kind of goes and often cries in a corner for a little bit. And then they come back and listen to the rest of the talk. So I don't want to talk about specific projects in here, but just some of the concepts that need to be covered. We need some sort of networking solution, and there are plenty of those. Virtualization, storage is a concern. Storage is different needs based on your use case. Healthcare, again, their storage of data has a whole bunch of privacy concerns. They also really don't have any option for losing data because, again, this is critical to literal human lives. Whereas something else like your farm that I mentioned earlier that is pulling data from sensors, they probably have a little bit more leniency. I'm not a farmer in the slightest, as you can't tell, but they probably have some leniency on when that data needs to be stored, how long, and so forth. And everything else on here, all the way down through to our orchestration layer, building on Kubernetes and just containers in general, and then to the onboarding pieces. That earlier slide about the zero-touch provisioning, how do we get all of these machines into our understanding, into our enterprise, because they are so widely distributed, and we may not have an IT staff on site. But I'll come back to that point. Slight variation on the previous slide I had for telecommunications, but I want you to notice on here all of the different vendors involved. This is another big problem as the telecommunications industry in particular is looking to get away from this single vendor that they are stuck with. And they are adopting these industrial standards, again, Kubernetes, your Linux-based operating systems, and so forth. All adopting this to give them the flexibility to move in the future, to give them the flexibility to pick and choose the pieces that they want. But all of this highlights, I'm sorry, I completely skipped a slide here. Another aspect of this is the peripheral discovery. So the icon at the center is a project called Akri. It services all of the protocols listed around this, plus I think actually quite a few others. If you know nothing about peripheral discovery and Akri, this alone should be enough to, again, to reuse the word scare you, to kind of scare you into realizing it's complicated out there. It's not a single easy way of connecting to this camera versus that sensor versus this fluid pump. All of these have their own kind of interfaces, their own capabilities, their own maturity levels. And this is something that an edge solution, again, not an edge product, but an edge solution has to take into account. And lastly, assume we have an entire edge solution in place. The same pieces that we've chosen suddenly are suspect to a lot of different environmental facets to it. So for instance, I mentioned earlier, low bandwidth and air gapped. It's very easy for us to test on normal bandwidth situations. But we actually have to remember that that's not always the case. So us showing, yeah, we're able to provision this machine from New Jersey over to Utah, that's cool. But what happens if you have a satellite connection to that machine? Or what happens if we're working in, I traditionally think of government when I think of air gapped, but the more I've started working in Edge, the more I've realized that this is a reality for a lot of different situations. Security. So FIPS is just one of the facets we're looking at for compliance, but what happens when the entire application, the entire suite needs to be run in a FIPS compliant environment? Performance levels, SRIOV, and how do we get this as close to real time as possible connections to things. Not every Edge solution is going to need that. Again, if you look at your local coffee shop, they probably don't need real-time reporting back. You look at things like telecommunications, they absolutely do. Yeah, Robert, I'd love to read more of your comment, but yeah, it's kind of scary when you think about, in a good way, don't get me wrong, that they have this kind of privacy. That's a bad way of putting it. But the amount of complexity added because you need to care about all of these rules or all these laws. GDPR, I'm glad you mentioned it because I meant to include it in this. That complicates everything, again, in a very good way. But it's things that we used to take for granted, or you can take for granted if you're working internally just within your own organization. But how do we design a product and make sure it's going to function with all of these different types of environmental factors, all of these different things that take the product and say, okay, this is great, and we're going to need to squeeze it to a slightly different direction. Yeah, right. I should have mentioned that too. I did say it's very easy to test on normal bandwidth. It is absolutely possible to simulate on low bandwidth and air gapped. In fact, we do our testing on that. But you brought me back to my actual point. We have to actively do it. And it's very easy to look at a traditional CI system and say, okay, cool, this provisions the machine, it's good to go. What we need to try to take into account is all of these extra environment variables, all of this extra complexity. How do we make sure we're testing all of it? And the simple answer is we're not testing all of it because that is an enormous undertaking. But this enters into stack validation. So we had the idea of taking very specific verticals, almost very specific use cases. And those are the ones that we are going to make sure have their own little section of CI that tests that particular configuration. Now, the first question anyone's going to ask is, okay, how is this different from CI? And I'll be honest, they're not completely different. So if you're thinking like, oh, this sounds like a CI/CD system, you're in the right ballpark. Whereas CD, this is a very simplified version of it. I have no idea how well the slide is going to play. I made this. I'm not a slides guy. I'm a code guy. But the idea is on the left. CI/CD is you traditionally have a product or a project, and you're doing your CI on it. All of those on the landscape CNCF slide, they have their own CI/CD systems. They wouldn't have survived incubation without it. So there's faith that the red box is going to continue to function. The green box is going to continue to function. Stack validation is similar-ish to acceptance testing or more systems level testing. And you can see that in the top image there of, yes, what happens when we combine all of these pieces together. I imagine I don't have to tell most of you that it's not ever as simple as, oh, cool, we just plug them together into a pipeline and they work. So we want to make sure that the full end-to-end suite of products actually behaves correctly. Again, fairly basic systems testing there. But it gets even more complicated, particularly in the Edge world, because we have such a wide variety of use cases. So we also have to take into account what happens if they decide they don't need the green box. Or in the case of the purple box, they already have bought into a specific tool for handling something. Let's call it networking, or let's call it storage. How are we going to make sure that our stuff plays nicely with those? On the top right, we have our red box, sure, but think back to the Acri slide and the sheer number of protocols, much less the devices themselves that implement those. It's absolutely staggering. So we want to pick and choose the most important, the ones we're hearing from our customers are, look, this is an actually validated design that we know needs to continue to function. And we want to have that as part of our stack validation framework, as part of our CI. The bottom right there, the Neapolitan looking square, we also have in the Edge world, people come to us and say, that's great. Can you shove it all onto one node because that's all we're shipping out to the coffee shop? That again, the pieces in theory all play nice together. But what happens when you actually get your hands on the hardware? And we can't just say, into our next concept, the trust but verify. Again, all of these CNCF projects, I have absolute faith in those engineers and the process they have set up, that they are going to continue working from release to release, and bad pull requests are going to happen, but realistically, they're going to be largely mitigated. But what we're looking at is the bigger picture. Let's take all these pieces and put them together, but not even just put them together under very specific outside environment situations. Ones that we've identified are the most common or the most risky, or let's call it what it is, the customers are yelling at us most for. And let's make sure we have those built and running so that way we can regularly tell the customers, yeah, we know exactly what you're doing is going to work because here's us showing it to you. Which brings me to point number 4. All of this is public. I have a link to it later, but the idea for all of this was meant to be that these different stacks that we're testing and the different permutations of all of the constraints and all the different hardware are visible to our customers, our potential customers, the open source community in general. This is not a huge surprise to anyone who has, thank you, Will, who has done anything with CI, but I want to talk through a few of these points that, yes, we have the obvious simple deployment. I've talked a bit about compliance and SBOMs earlier and things like the hardening. FIPS, turning on FIPS mode, turning on SE Linux in and of itself. We want to make sure that these situations are actively tested inside of our pipeline. Going further to high availability, again, this is going to vary very, very wildly based on your end user. Something like a coffee shop, they probably can afford a small outage. Depends on what time of the day. I mean, when I don't have my caffeine, it can get a bit dangerous. So that's maybe not a great example. But look at healthcare. They don't have that option. They need to have a highly available system. They need to ensure that it's going to continue to function, and they need to know immediately when it does not. Up to chaos performance. This is a little more applicable in the telco world where, man, I have seen asks at the level I have never seen before of the fine-grained performance metrics that telecom needs to facilitate. I'm not saying they're weird for doing it. It's just I've never really thought about it. I just kind of complain when my phone can't connect or to, like, blips out when streaming something. Now seeing the other side of it, we need our product that is answering all of these different things to also be able to perform at that level and continue. Day 2 scenarios. Thanks you for that, Joe. Holy cow. So the comment from Joe, Dan Walsh, thanks you for not just disabling SE Linux. I'm going to pass that on to my team because the amount of times that we have just said, well, I just turned it off so that way it would work, and we've gotten kind of slapped on the wrist by someone in management. I actually know Dan, he would very much appreciate that. But yeah, there's a reason he made that joke, right? Like disabling SE Linux is the easy way out of a lot of these types of situations. We unfortunately don't have that luxury. So we need to be able to understand, hey, the application for people who are going to care about it is going to be able to need to conform to FIPS compliance. All of that really boils down to day 1 types of scenarios. Once we get into day 2, it is an entirely different story, which is even more difficult. You start factoring in, how do we do a massive upgrade when we have low bandwidth or when we have an air gap situation? How do we handle these situations where we don't have an IT staff on site? Back to my coffee shop, I keep saying, they likely don't have somewhat trained IT staff on site that is there to maintain these systems. As the IT organizer for that company, you want to be able to know from a central location, like, yeah, I can fix this for them. I can push out these updates. I can make sure the security vulnerability is patched without having to find someone on site that has the expertise to do it. I include this. This is the closest thing I have to a demo because unlike Flynn, I'm a coward. But all of this is live on the URL down below. And this is our first pass at it. The idea of how we're going to visualize these situations for our customers, for the open source communities. On the right side, the big thing I want to point out there, because this is not unlike any other UI you've ever seen for a CI system, but the scale of the amount of parameters, I tried to capture it on the right there. You can see all the different files, and I promise you that list goes on and on and on. Being able to view them, being able to understand, okay, these are all of the different configurations that apply to my management cluster, that apply to my downstream clusters, that apply to the nodes and devices they use. All of that becomes very, very relevant to be pulled up to a high level and visualized for the people viewing this, to not just assume, yeah, this works. Totally a coward. I've done live demos before. I just didn't sacrifice anything today. How do we pull this stuff up and make it obvious that this is what makes this environment different from another? So I'm actually doing quite good on time. I have 3 examples I want to end with, and I've alluded to a bit of this as I've gone. But we have container ships. In hindsight, choosing container ships is a really bad unintentional pun on the fact that we're using containers. I've probably used this container picture of this ship a dozen times already when it comes to talking about containers. But let's go with ships for now. Low bandwidth, satellite situations where it's not just low bandwidth, but it's expensive. And to the earlier question from a bit ago, unreliable networks. We need to be able to debug these and troubleshoot these situations at sea when we don't necessarily have a very reliable, very high bandwidth situation there. Worst case scenario is that the ship has to come back to port to get something debugged. That is never going to be a good look for the IT department, for the products involved in it. So one of the things our stack validation is looking to do is literally simulate this exact situation of how to making sure that we have environments where the bandwidth is intentionally throttled, where it occasionally drops out. On a previous slide, I saw chaos on here that I forgot to specifically comment on. But this is absolutely one of those situations where we would want to be able to throw this unreliability into it and see how the application resolves itself. Joe, the cruise ship thing, it's funny you say that because I went on a cruise over the summer and my family is, my wife is non-technical and my kids are kids. The whole time I'm pointing out, I'm like, this is exactly what I do with, oh God, you heard the dog. I've been trying to keep him quiet. I'm sorry. He's a turd. He's just been anxious all day. No, on a cruise ship. So we went on a cruise over the summer and the whole time I'm like pointing out the systems to my family. I'm like, I was like, this thing right here, like just the fact that we can log into our doors. I'm like, and they don't get it at all. So I'm glad that there's some fellow nerds here that can at least go back to the, well, he's there for you, Lisa. So I'm glad that someone else made the cruise ship reference because I've been thinking it as well. But yes, so anyway, I've kind of harped on this ship one for a while now. And we've talked about medical a bit over the course of this talk. You know, I want to focus back on the critical patient data. There's going to be different replication schemes that we need to be able to see in action and verify that they work as advertised and verify that the failover situations work. So again, back to that chaos testing, one of the things we like to do is we have to break stuff regularly because it's not just a situation of, oh, bounce a server. It's, do we even have access to the device anymore? And in these situations with the patient data, you can't just say, oh, sorry, we lost the last 2 minutes of heart rate data. Just wait 2 more minutes and you'll get it back. That's not, I'm not a doctor, but I can't imagine a world where I say that to them and they're at all happy with me. Real-time performance, I mentioned this earlier too. You don't really have a great opportunity to just be like, yeah, we'll eventually find out that so-and-so's in cardiac arrest. That got morbid. Let's keep moving. The uptime and the recovery is going to be critical. And this is another situation where your on-staff IT department, no, not necessarily trained in this level of administration. They've got plenty of other things to focus on. Having a way of actually automatically recovering from any outages or making sure that as the updates roll out, they are successful and they don't have a problem where it needs to be rolled back. Having all of that automated behind a suite is absolutely critical. And that's something we have to make sure that we verified. Otherwise, we can lose a lot of faith very easily in the medical community. All right, Robert, we're going to leave that one alone. Major cruise line. Yeah, again, Joe, I had non-technical people with me because I'm sitting there thinking the same thing. I also think it when I go to Disney World. My dad was in tech, and we would we used to go and bring my kids, constantly be talking about like the improvements. I'm like, do you understand like how crazy it is that this fast pass system didn't exist and they managed to jam it back into. All right, I'm off topic. Last example here. I'm still pretty good on time. A fast food restaurant. I feel like I should mention, again, I'm an engineer, and one of the things I've learned in engineering is you never mention customer names. So I needed to pick some kind of fast food image that is not real. If for some reason Breaking Bad has spawned off I'm not going to brutalize you with my Spanish, their chicken fast food restaurant into real life, I am not in any way saying Sousa is a customer of them or they are a customer of us. I needed something fake. And it was very, very difficult to find a fake fast food restaurant. Important things here. The employees are not necessarily going to be technical. On top of that, they're not even really going to be that disciplined when it comes to technology. We say it as a joke, but it's not absurd to think of a situation where they unplug some critical backup or use the UPS system, like leave it running, so that way they could charge their phones or something like that. Not mentioning names, here we go. I do quite like Chick-fil-A though. But yes, so we have non-technical staff and just literally no one on site that can possibly do this kind of stuff. There's also the security of someone can just physically walk back there and pick it up, even more so if it's a nuke, Hugo, because it's even lighter. So that's an entirely different set of constraints that we have to understand what's going to happen. What happens when we employed with these heavily encrypted disks? Heavily encrypted sounded really, really corny, like some kind of like hacker thing. But you have to work with encrypted disks. You have to work with the ideas that this machine may unfortunately get up and walk away. And how do we make sure that the data on there isn't compromised? And then my last point before I give Will a chance to jump in, a lot of these are going to be a low hardware footprint. One of the weirder things we've been asked for is 2-node HA, which I understand, but is also kind of an oxymoron in and of itself. So it's great when we can throw things at our lab and see, oh, cool, this runs. Watch, I'm going to press a button and spin up 12 VMs and watch a whole running environment all on a single VLAN. But what happens when we're looking at low commodity hardware, or we try to shove everything on a single node and we need to understand how all of the processes and activities that worked when we were distributed suddenly work potentially different. Future considerations, if you want to bring Will up, I can quickly talk through the other things that we want to keep in mind for the future. First two are very closely related, stack validation in a box. So instead of having this outside system, how do I make it so developers can run this locally, or at least as much as possible, and open up our developer contribution? Our developers have been awesome in actually contributing quite a bit to it so far. It's very important to us. So we want to make that a little bit simpler, and then want to make this a customer deliverable. So, hey, that's great. You bought our product. We want you to be able to run this inside and show, yeah, we weren't lying, that everything we told you was going to happen, you can prove yourself on your own hardware. Will?
Yeah, actually, we realized we didn't properly introduce Will when we first started. Will is also a CNCF ambassador and a KubeCrash alum. And we love it when our alums, our KubeCrash family, come back in and join us for Q&As to keep these things going. So thank you, Will, for coming. Will's coming all the way from Amsterdam. Thank you so much for staying up late and for being a part of our wonderful KubeCrash family. So we're going to let you handle the Q&A for this one because they've seen enough of us. So you can ask some of the questions in chat, or you can really just ask Jason whatever you want. I know you guys go way back.
Oh, yeah. Thanks, Danielle. Thanks, Lisa, for having me. Hey, buddy. So I have some questions that I would like to ask you about platform engineering. But before we go there, I've seen a question that I didn't not want to answer in chat. I know that you would have loved to answer that one, so I'll let you do it. It's from Raul Singh, and he's asking, how does Kubernetes help with air-gapped scenarios for embedded environment, especially in the case of management of state changes or changes in the device model deployed? Go for it.
Okay. Okay, thankfully this is something I can ask. I was going to joke that like there's a reason I didn't answer it because I didn't have one, so I just let it keep scrolling. I'm actually okay with this one. So the thing to keep in mind about air gaps, and this is a big mentality issue for me, it does not necessarily mean a single machine with absolutely no network connectivity. It just means that the entire deployment, the entire setup doesn't have public internet access. So yes, there's hoops you have to jump through to introduce new content, like new images, updates, things like that. Yes, there are hoops you have to jump through in terms of visualization, if any, from externally. Internally, though, it's still Kubernetes. And it's even nicer because you can rely on all of the kind of self-healing of Kubernetes to do the things that are underneath the air cover, the air gap that I don't necessarily see. So I don't have to be there policing the air gap situation and say, hey, is this still running? Is this still running? Does this need to be moved? Kubernetes takes care of all of that for us. So we're able to leverage that across the environment and take advantage of it in many of the same ways that you would a normal Kubernetes deployment. Especially in the case of management state changes or changes in the device model deployed. Not 100% sure I follow. What I can say is I think it plays into that in a very similar fashion that Acri, the things we've talked about today, all run cloud native, so they're able to run the discovery. And if they have the modules installed for those protocols, it will find the devices on the network. After that, how much of that you want to propagate outside of the air gap versus inside? Again, I'd go back to keep in mind that air gap does not just mean a single machine. It means the entire environment doesn't have public internet. So a lot of what you get out of Kubernetes for free is the same benefits you get in the air gap situation.
Absolutely. I did not see any questions that you have not answered, Jason, sorry. I don't know why I said David. So I'm going to move on with my questions. So in the validated stack is absolutely interesting, right? And it makes a lot of sense. What I want to understand is how does platform engineering addresses the development of edge workloads? How does it accelerate the development of workloads? How it reduces the let's call it an ROI of the initiative, but yeah, let's focus on the acceleration for the moment.
Yeah, it's a great question. So it's very, sorry, I'll click myself here before I answer this one. Having the ability as an engineer, being able to, we obviously have to take into consideration low bandwidth. We have to take into consideration low footprint hardware. We have to be aware of all of these things, all of the compliance pieces. But again, the joke before about disabling SE Linux, let's be honest, we're engineers, and sometimes it's just kind of easier to just do it sloppy and eventually, you know, hope it doesn't break and figure QA is going to find it. This catches it a lot sooner because, you know, we've done testing on FIPS, but it's not something that regularly influences my life. I generally don't interact with satellite bandwidth. So being able to take them into account from a design, from an implementation standpoint, but then also leave it to the system and say, look, I'm going to know very, very soon if something falls apart once this actually hits the system is key. It's absolutely crucial to our developers. So that way it's not, oh, 6 months from now, we have a release out and so got their hands on it, and oh, they happen to be running it on 3 nukes in a back closet or something like that. If we have these types of major known scenarios, and again, it's not exhaustive because it's literally impossible to be exhaustive. I use 3 nukes as an example because it came up in chat, but realistically, I honestly don't know if we have a 3 nuke setup. But I do know that we are aiming to build out this environment where these types of situations are covered. And that gives the developers a chance to make smart choices, but then also be verified that their choices were in fact smart and don't fall apart, and be told very, very soon. So this isn't a ton of backporting or a ton of figuring out what went wrong. If I break something, it's pretty obvious that I broke it, and I'm usually the one who breaks things. So me of all people benefit from this.
Thanks, Jason. So from what I hear, so in platform engineering, we are always talking, we're always going on and on about this platform catch-all scenarios and all these things, which I particularly am not a big fan of. I believe very much into a domain-specific, purposely built platform with interfaces that reduce as much as possible the adoption of the platform itself. So from what I hear from you, you agree that a platform for edge should not be also doing something else than edge. So it should be very specific, validated, as you say, trust but verify with workloads that are going to be working very well with those specific use cases that the platform is validated for. Good. I like it. Go on. Sorry, you want to say
something? No. I was waiting to see if you turn that into a different question, if you just wanted my comments on it.
If you have comments, shoot it. But I was
probably nothing I haven't said in the past half an hour, so I won't reiterate.
Okay. So you have the platform is the stack is validated. Fantastic. So I want to take this and I see in the questions everybody has something to say about edge. I love it. But I want to abstract the edge part from it, and I want to take into terms with what we all know about platform engineering and then bring it back into the edge. So when we're talking about automation, I have this validated stack. When we are talking to people that have not been doing edge, they're not playing around with satellite the whole day, at least I'm not. How do we ship software? How do we use those practices that we know from platform engineering, like with all those GitOps and CI/CD, all those nice things that we do for automation? How do we guarantee it in the edge validated stack using the practices that we know from platform engineering? Is there an automation framework that you guys have set up that we can leverage?
So not a framework so much as a solution, to use my own terms on product versus solution. It is not something that we have easily necessarily bought into one tool that does everything. We use some Ansible, we use some libvirt, Redfish, especially with, I believe it's Sushi Tools, can actually simulate a Redfish connection for BMCs. A couple of different frameworks for actually running and executing the tests. Outside of that, though, it does feel very much like your normal types of practices. And that's where it's really good following Flynn, actually, because, and the idea of the not needing an army of SREs, because since it follows most of the existing practices you would expect, under the covers, it can do the added pieces for Edge. And that's not really bubbled up from a developer view or a process view. Like, it doesn't, like you said, it's not something that I have to regularly interface with because it is covered on its own. I feel like I'm kind of going back to your agility question from earlier, but it's really not that different because we can encapsulate all of that underneath the stack validation platform and obviously have access to it for debugging purposes. But it lets us just continue to do things with the normal speed that we would get in a less complicated environment, with the understanding that, yeah, this is running for me. I know it's going to be there. I know it's going to be taking care of a lot of these really weird, hate to make a pun here, these edge cases. And believe me, that's not the first time I've groaned when I've said that. It's not great that the word corresponds, but it will keep an eye on all of those for me, so we don't have to change things. You come to work on my team, you're not doing anything wildly different than you would in most engineering organizations.
Fantastic. I think we are okay with the time. I would be told if we were not. So I'm going to ask one more question. Sorry, two more questions. First one is something I'm very interested on. It's services, right? I believe that a platform should always provide as much as possible automatic and out of the box things. One of the things that I like to be is discovery of services. When we're talking about Kubernetes, we have that. We got that covered, right? But when we're talking about edge, we have the far edge or the very, 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 very far edge that is not necessarily a part or a device that is a part of the cluster. So it's not in the Kubernetes cluster. but I still have to treat those services deployed in that device as I want to as part of the cluster. So in this validated stack, my question is, do you have a plan or an idea of to do this automatic discovery of services at the edge outside of the control plane of Kubernetes?
Yeah, that's been on our radar since minute one. Yeah, I showed the Acri project. Didn't talk too deep about it. There's a guy on my team who's significantly more well-versed in it than I am. But that handles a fair amount of the discovery, and it obviously doesn't pull them into the cluster in the sense that it's a first-class member that I'm interacting with, but it gives me the API to do it. And it will actually add it as inventory items. I'm 99% positive on this. Please don't come back and yell at me if I'm wrong. But it will function as that inventory and that discovery aspect. Otherwise, if you're talking about at the more machine level, our nukes, our machines running out in the telecom towers, they have their own means for either, again, calling back to us and saying, hey, look, this is, I was told that you're supposed to manage me, go forth and manage me. Or in more traditional hardware situations where we actually do know the hardware ahead of time. Like I said, with the directed provisioning, we have that. But I know that's not what you're asking about. It all comes down to the projects. It'd be so great if I just answer a completely different question. It's like, next. You know how many times I wanted to do that? No. But honestly, we're working with products. Acri is the first one that we have spent a significant amount of time with because it gets us a lot of that way and has a variety of different protocols for detecting all of these. I'll cut it off.
Acri.
Yeah, Mike, A-K-R-I. You could probably just Google that. If something else comes up, I'd be kind of floored.
Yes. So just to finish on that question, and then I have one more. At least I know you want to kick me out.
Give us the hook, man. And I haven't really stumbled through your questions yet. Let's just take it on a win.
Take it on a win? Okay. I was very much interested in the service mesh aspect of the edge, not specifically for telco, but thinking of things like Linkerd, right? That we can add workloads from the edge, not necessarily being within the cluster. So we can get those services in the Kubernetes cluster, but they're not part of the Kubernetes cluster. So I'm interested. And now really my last question, which is, I know, Jason, from a little bird, that you are among a group of very nice guys that have been writing a book. I want to know when that book is out.
Holy cow. Okay. I was very scared when this started because I didn't know where this was going. I'll very quickly, I promised to Danielle and Lisa, I'm not going to sit here and plug something, but since you brought it up, the Edge team, we got together and did a book sprint. And over the course of the week, trapped in a conference room in Washington, D.C. in a hotel, we wrote a book from start to finish on Edge. The process was really cool. Can't talk about that now. Would love to talk about it with people because it's really nerdy stuff. We're looking to have copies of that at KubeCon this year. And I promise you, me and William did not collaborate on that ahead of time. This wasn't some kind of like pitch.
He didn't know, I would ask. He didn't know.
Like I said, I was generally worried where this was going. No, the book we should have in print, available at KubeCon. We're doing, I believe, book signings. And don't quote me on that, but I'm almost positive we're looking to distribute that in our booth at KubeCon.
So you're going to send me a book because I'm not at KubeCon. You're going to send me a book because I'm not at KubeCon.
Sign it and send it to you.
I want Basil to sign it too. I want a book also. I'm so glad you asked that question, William, because I was going to ask about that. I had heard about this project, and I also heard about the process and everything that went into it, and it was spectacular what you all did. Spectacular.
I feel like we have a lightning talk for
I know
how to write a book in a week.
Some serious security experts, and I actually, threw it out there to see if Basil wanted to talk about it. But we did a zero trust day. We did that in a different Kube Crash. But super glad that you asked that. We will make sure you get a copy. And yes, we are going to move on, but I am glad that someone gave Chick-fil-A a shout out, because those of you who have been at Kube Crash for a long time will remember that we had Chick-fil-A, Alex Crane to be exact, come and do the opening keynote at the second Kube Crash. I believe it was the second Kube Crash ever. So Chick-fil-A is a Kube Crash alum also. So we are happy to give them a shout out. And they're doing some great things with Kubernetes, with K3s, I think, too, right? And some of the edge stuff they're doing. It's pretty amazing what Alex walked through. So for those of you that want to see a great presentation, go to kubecrash.io, go to past events, go to the second one. I don't even remember. I guess that was 2022 fall. I'm going to say 2022 fall, I think. I could be wrong. But yeah, I think we all met in Detroit after that. So.
Well, thank you both. I am going to remove you. It was a pleasure having you here.
Thanks, everyone. Great to see you all again.